In ancient times, people consulted oracles when faced with life's tough decisions. You may still ask a magic 8-ball if your team will win the big game, or delight in a fortune cookie that reveals you'll marry your crush. It's all part of mankind's eternal struggle to know our fate. But did you know math can also tell you about the future? What if I asked you, will it rain tomorrow? How confident do you feel about your forecast? It depends on how much you know and don't know, right? That is, the more you know, the more certain you can be that your forecast will be true. This means that certainty can be measured or quantified. In the world of math, this measure of certainty is called probability. This kind of math can show us how likely or probable a particular event is. If we are totally sure something is going to happen, it has a probability of 100%. If we are sure something is not going to happen, the probability is 0%. Many things in life fall somewhere in between. An event that has a probability of 5% probably won't happen, but there is a chance it might. In fact, there is a 1 in 20 chance. On the surface, calculating probability is a simple matter of division. You divide the number of favorable outcomes by the total number of possible outcomes. It is second nature to try to make this mental calculation in our heads, like when we get a hunch about something. But people are not hardwired to understand probability. Even people with strong mathematical skills get probability problems wrong using intuition alone. In this module, you will be presented with the famous Monty Hall game show problem. In this problem, you can choose between 3 doors. Behind one is a car. The other 2 have goats. After you make your choice, Monty opens one of the other doors behind which there is a goat. Monty then asks you if you would like to switch your choice. Most people's intuition would say switching wouldn't change your chances of getting a car. It would still be 50-50, right? In fact, famous mathematician Paul Erdős refused to believe it mattered until he saw a computer simulation showing the outcomes. It turns out it does matter, and in this module you will learn more about why. Risk and probability go hand in hand. If I go over the speed limit, what are my chances of getting pulled over? If I smoke cigarettes, what are my chances of getting lung cancer? When we say something is high risk, we mean that the probability for something bad happening is higher than 50%. You don't have to go skydiving or wrestle alligators to encounter risk. Say you are booking airfare. You have a choice of 2 types of tickets: refundable and non-refundable. The non-refundable ticket is much cheaper than the refundable one. Why? Well, if you chose the refundable ticket, you are paying extra to reduce your risk to 0%. If something goes wrong and you can't take the trip, you can get all your money back. So, when choosing a ticket, you have to estimate the probability that you won't take the trip. In fact, many businesses specialize in using probability to manage risk. Insurance companies are one such business. When you buy car insurance, you are paying a company to gamble on your likelihood of damaging your car. If you never get into an accident, the company gets to keep all of your money. On the other hand, you might wreck your car and the company loses the money you paid them and maybe even more. Insurance companies spend a lot of time trying to gather as much information about their policyholders as possible. The more they know, the more accurate their probability calculations will be. Of course, the most obvious example of a business that deals exclusively in probability and risk is a casino. Casinos aren't the real world. They're an artificial environment. The casino makes the rules. Casinos use something called the house edge to win more than they lose. Consider American roulette. When the wheel is spun, one ball has 38 places to land. This means that the probability that the ball will land in a particular spot is 1 out of 38. The word odds is used a lot in gambling. The odds for an event are the ratio of the probability that an event will happen to the probability that it will not happen. You'll learn how to calculate odds in this module. In roulette, the mathematical odds for landing on a particular spot are 1 to 37. So in theory, if you bet $1 that the ball will land on a particular spot, and it does, the casino should pay you $37. But they don't. The house odds for roulette in most casinos are 1 to 35. This means if the ball lands on your number, the casino will pay you $35. $2 less than what is expected. This is the house edge, and it's how casinos make money. For roulette, the casino makes 5.26% profit thanks to the house edge. Casinos are playing the long con, so to speak. They make money by being more right than wrong over the long term. They are exploiting something called the law of large numbers. This means that the more times the game is played, the closer the casino's average number of wins will approach the house edge. Some people will bet only once and leave the casino. Some will stay for hours. Some will win and some won't. But the casino doesn't have to beat every player every time. Over the long haul, they'll always win 5.26% on their roulette game. That is, for every $1 million that is gambled on the roulette wheel, the casino will always make about $53,000 in profit. This is called the casino's expected value for roulette. You'll learn about how to calculate expected value in this module. One of the trickiest things about working with probability is calculating the number of possible outcomes. One way is to draw a tree diagram. For example, how many outcomes are possible from rolling two 6-sided dice? A tree diagram can link up each possible event for one die with each possible event from the other die. Then you can just count the number of lines and voila! You've got your number of outcomes. Wait, but look, if you just multiply the number of outcomes from one die by the number of outcomes on the other die, you get the same answer without all the laborious tree drawing. This seemingly magical trick is called the fundamental counting principle and can be a lifesaver when working with large numbers of outcomes. If we apply the fundamental counting principle to a pack of 52 cards, things get a little more crazy. How many different ways can you stack a deck of 52 cards? Well, there are 52 choices for the first card. Once that choice has been made, 51 cards remain, leaving 51 choices for the second card. So altogether, that's 52 times 51 choices for the first two cards. 50 choices remain for the third card. So now we have 52 times 51 times 50 choices for the first three cards. We continue like this all the way down to 2 times 1. This is a factorial, and it's written like this. The actual number of 52 factorial is 68 digits long. A simple deck of cards can be arranged in more ways than there are molecules of water in all of Earth's oceans. A randomly stacked deck of cards has probably never been stacked exactly that way in all of history. The mathematical tools of probability help us tame seemingly unfathomable numbers of possible outcomes. The world we live in is ruled by chance. You never really know for sure what will happen next. It is often said that fate is untamable, unpredictable, and ultimately unknowable. But with the mathematics of probability, we can make a very educated guess. Probability can give us valuable insight in our constant struggle to harness destiny.